Hi, this is Mrs. Basin, and today we're going to review how to name compounds. So in the last writing formulas review, we talked about the difference between ionic, covalent, and acid. So when you are writing the names of compounds, you have to figure out what it is first, because all these different types of compounds have different naming conventions. So we're going to start with ionic compounds, which is a metal and a nonmetal. So when you when you name an ionic compound, you're going to use the name of the first element, the root of the second, and you're going to add IDE. So we're going to look at a couple examples. So my first example down here is LiCl. So name of the first element, Li, is lithium. So this is lithium. And then the root of the second element, so chlorine, is chlor. And then we're going to add IDE. So LiCl is just lithium chloride. Our second example, CaCl2, name of the first, calcium, root of the second, chlor, add IDE, and that becomes calcium chloride. Okay, now they get a little more complicated if you have a multiple charge metal. Now in this case, the Roman numeral is going to show up in the name of it. So you have to kind of familiarize yourself with what those multiple charge metals are, so you know when you would need Roman numerals and when you don't. So you only use Roman numerals when you have atoms that have multiple charges, and you have a list of those, and eventually those will become familiar as we use them. And the Roman numeral is going to indicate the charge of the metal, so the original charge of the metal. The rest of the convention is very similar. It uses the name of the first, root of the second, IDE on the end. So here we have copper in both of our compounds, and we know copper is a multiple charge metal. So in this case, to figure out what the charge is, you can kind of think of it two ways. You can either think of it as kind of uncrossing the charges, so you kind of pull this back up. Okay, now that can get a little tricky if those charges have canceled out, so I'm going to show you a second way here. But this case, this would be copper. And this 2, copper was originally a +2 there, so copper 2 chloride. Now without uncrossing those charges, which is probably not the safest way to do it, sometimes you can get away with that, that's probably not the safest way. If we look at this again, a better way to do this is to look at the second part, because the second part of this is always going to have one possible charge. So chlorine we know is a -1. Okay, and there's one chlorine there. There's that little implied 1 that we don't write, so that's a -1. This whole thing, oh, I'm sorry, there was a 2 there, so ClCl2. Okay, so this was my original compound. So chlorine is a -1, and there were 2 of those, so that gives me a -2. I know this has to give me an overall charge of 0, so you can look at what does that copper have to be so that the overall charge is 0. So in this case, copper would have to be a +2 because there's only one of them. So that would then give me that overall charge of 0. So then that tells me my Roman numeral has to be a 2, like we did down here. Okay, let's try the second one. This one, CuCl, and I'm going to do this this way up here that we just looked at. Okay, so CuCl is our original compound here. Chlorine, I know, is a -1. That's always its charge. And there's one of them, so that's a -1. So for this to give me a charge of 0, if there is one copper, that copper has to be a +1 charge. So that means that this copper is copper 1. So when I write out the name, this is going to be copper 1 chloride. Okay. Okay, the next type of ionic compound is you can have those polyatomic ions in there. So these, you can have the name of the first and then the name of the polyatomic ion. So in this case, sodium, Na, we start out with that, so name of the first. And then OH is one of my polyatomic ions. Again, that's a good reason to familiarize yourself with those so that you can pick those out when you see them when you're naming. So OH together is called hydroxide. So this would simply be called sodium hydroxide. Second example, magnesium is the name of our first one. This is just an element. And then CO3, if we look that up on our sheet, is carbonate. So this is just magnesium carbonate. There is one positive polyatomic ion, ammonium, so it is possible to have two polyatomic ions and have to name them that way. For example, we could have NH4OH. So this is a polyatomic ion and this is a polyatomic ion. So in that case, we would just use the name of both of them. So NH4 is ammonium and then OH is hydroxide. So that would just be ammonium hydroxide. Okay, our next example are covalent compounds. So covalent compounds, remember, are nonmetals and nonmetals, and these are the compounds that use prefixes when you name them. So when you do this, you're going to use the name of the first element, and you only use a prefix if there's more than one. The second element always gets a prefix, and then it ends in IDE. Okay, so our first example here is CO. So my first element, there's only one of them, so I don't need a prefix. So carbon. Second element always gets a prefix, so there's one, so it's mono. And we're going to drop the double O's there. So instead of monoxide, we're just going to call it monoxide. And then it ends in IDE, just like our other compounds did. Second example, C2H2. Since there's more than one of my first element, I have to use a prefix. So 2 is di, so this is dicarbon. And then 2 of my second element, so dicarbon, dihydride. So you always have a prefix on the second, prefix on the first if there's more than one, ends in IDE. Okay, my last naming system that I have to worry about are binary acids. So, or acids in general, but we have binary acids and we have oxyacids. So binary acids is going to be hydrogen and another element. So when you're doing this, you're going to start with hydro. So the only time you use hydro if it's just an H plus one other element. So use hydro, the root of the element, and then IC. So this first example is going to be hydro, and then the Br comes from bromine. So brome, and then ic is my ending. So this would be hydrobromic acid. Same deal for this one. It's a binary acid, so I'm going to start with hydro. Iodine, hydroiodic acid. Okay, so the last group we need to worry about are oxyacids. So oxyacids are hydrogen and a polyatomic ion that contains oxygen. So when you name oxyacids, you want the root of the polyatomic ion. Notice you're not using hydro, so there's no hydro if it's not a binary acid. And then 8 goes to ic, ite goes to OUS. So again, I8 acid, I feel icky is one way to remember that, and then ite goes to OUS. So when we are naming this, what we have to do is figure out what that polyatomic ion was. So NO2 was nitrite. So ite goes to OUS. So this becomes nitrous acid. Okay, no hydro, that's it, nitrous acid. Same deal on the bottom one, NO3 was nitrate. 8 goes to ic, so this becomes nitric acid. Okay, so again, oxyacids, no hydro. You look at what the polyatomic ion was. If it ends in ite, it goes to us. Ends at 8, it goes to IC.